Hello, everyone, and welcome to the Esri Federal Technical Webinar Series. This technical webinar series was designed specifically for federal government professionals who rely on Esri's ArcGIS technology. The series has a total of 5 webinars that you won't want to miss. Each webinar can be found at the URL you should see in the chat. If you missed the first one, that's okay. We did record it. It was the ArcGIS Geospatial Platform, a technical overview, and you can soon access the recording later this week at the same URL that you see in the chat. If you enjoy this webinar and or would like to catch the rest of this series, be sure to register at that URL. This webinar today and all webinars within the series are recorded. Throughout the webinar, should you have any questions, please feel free to submit them into the Q&A tool that you may see at the bottom of your toolbar there. You can send in questions at any time throughout the presentation. We will collect them and address them during the Q&A portion of today's presentation at the end. Now I would like to introduce you to our webinar, Strategies for Scripting and Automating Using Python, presented to you by Nick Ginner, Product Manager, Analytics and Data Science, and Manushi Majumdar, Product Engineer, Applied Data Science. Over to you, Nick.
Okay, thanks, Amy. I'm going to share my screen here. So my PowerPoint slide should be coming up. And thank you again for joining us. And so as Amy mentioned, this session is going to be mainly about Python and a lot of different ways to use Python with ArcGIS. We're going to start off with just kind of a quick overview of how Python is manifest across ArcGIS. And really, we're going to spend the most amount of our time actually seeing it in action. So we'll see a few different demonstrations of Python for analysis and data science, for administering a GIS organization, for managing content across a whole range of technologies. So let's just jump right into it. So in general, as you may be aware, Python is a programming language. It's one of the most popular programming languages in the world. It's been around for 30 or so years, and it is widely used and it's widely taught in universities. So it has a very strong and vibrant user community, and that covers many different domains. It's not just about GIS. And basically what this community does is they build these things called libraries, right? And so libraries basically are sets of functions and methods in code that allow you to essentially use Python for your work. And so within the community, there's about 600,000 of these for pretty much everything under the sun, from AI and machine learning to scientific computing to many other things. And broadly speaking, people use Python to build software and to develop it. They use it for scientific and mathematical, statistical analysis. They use it to automate their tasks, which you'll see some of today, and they use it for geospatial data analysis, and that's kind of where we sit today. So our customers have been benefiting from this kind of tight integration of Python and ArcGIS for about 20 years or so. And sort of where that shows up, we start on the left side. We have, out of those 600,000 in the community, we have 2 Python libraries. So ArcPy is essentially programmatic access to the 2,000 functions of the ArcGIS geoprocessing framework. It can be used for managing data, for spatial analysis, for automated mapping. The ArcGIS API for Python, the second Python library, is really what is used to script against your WebGIS. So our customers use it to automate WebGIS workflows, administering organizations, managing content. And it's actually also where we have something called the spatial-enabled data frame, which is really important for moving data between ArcGIS and the open data science ecosystem. So we'll see a bunch of that today. And so, I'm sorry. What we'll also see today is how these libraries could be used in several different experiences. So they could be used in ArcGIS Notebooks, which are essentially a Jupyter Notebook experience built into ArcGIS Enterprise, Online, and Pro. You can also write Python code in ArcGIS Pro and Notebooks. You can write it in your own IDE of choice. And you can also build custom tools and publish these out for consumption across an organization. So between the Python libraries and various experiences, as well as a very tight integration with open source Python libraries, it's really, really powerful for solving complex problems that kind of require the best of ArcGIS and the best of Python. So that's kind of a high-level overview, and you'll see quite a bit of this today. We actually deliver Python in ArcGIS. So for example, in ArcGIS Pro, you get a Python environment that has both of those Python libraries, as well as about 300 other open source Python libraries. But of course, you could customize this environment and you could add your own libraries to that. And then in the ArcGIS Notebooks product, both in online and enterprise, we have this concept of the notebook runtime, which is basically, again, a Python environment that has the Esri Python libraries, as well as a couple of hundred other open source Python libraries. So again, the ArcGIS products ship with Python, which makes it easy for you to use Python in them. And with that, I'm just going to get right into using some Python. So my section of this presentation is really going to focus on using Python to script and automate analysis and data science workflow. So let me jump into ArcGIS Pro, and I'm just going to paint a picture of what I'm going to be talking about here for about the next 15, 20 minutes. So we're looking at a map of the US, and each one of these regions in the US is a climate region, so similar precipitation patterns, similar temperature patterns over time. And this was defined, these regions were defined in the 1990s by the National Centers for Environmental Information. And as you could tell, or as you could see, the boundaries of these climate regions all pretty much align with US state boundaries. And, that's, if we look at a map of average precipitation over 30 years, that's not the way that natural phenomena like precipitation or climate behave, right? They don't follow nice, clean lines. And so what my goal is to basically take a large amount of historical climate data, and instead of having precipitation regions that sort of follow these state boundaries, create a new map of precipitation regions that are much more aligned with and much more representative of true climate patterns in the US. So that's kind of what the goal, that's kind of what the problem is, and what the original, or what the end goal is. So let's jump right into a notebook in ArcGIS Pro. And as I mentioned, essentially what we're going to be doing here is we're going to be starting off with about 11,000 rasters, right? And each one of these rasters represents daily precipitation. So precipitation on January 1st, 1981, precipitation on January 2nd, 1981, all the way to 2010. So we start in 81 and we end in 2010. So it's a big stack of 11,000 rasters. And the goal is to end up with a data set that's a table where we have every location, we have locations in the US, and each one of those locations has a number of about 16 different precipitation variables. So like the average fall precipitation, the average spring precipitation, et cetera, et cetera. So I'm going to start off by showing you what one of these data sets looks like. So this is a CSV file, and in this CSV file, we have essentially two columns, which as GIS folks, I think we all get excited about when you have a spreadsheet that has X and Y coordinates. That means you can map it. So we have coordinates, and we have a column here for season year. And in this particular spreadsheet, I only have, I think, one option here. So this is all of the precipitation information for the winter of 1986. So it's one season. And those attributes include the total precipitation at that location in the winter of 86, the number of days in which there was precipitation, and two other measurements of precipitation. Now, these aren't really all that relevant, but the point is that they both kind of are a measure of a precipitation pattern within a season. So for example, this Gini coefficient, it has a range of 0 to 1. And basically what it means is that, if you're close to 0, basically all the times that it rained in a month were kind of equal amounts of rain. If you have a Gini coefficient of close to 1, it means that for all the times that it rained in a season, there's kind of a bunch of inequality or variability in how much it rained. The other measure is this Lorentz symmetry coefficient. And basically what this means is like if you have a value of less than 1, it means that it rained a whole bunch of times, but just a little bit. And if you have a value of greater than 1, that means it rained just a few times, but a lot of rain each time. So the point is that we have these 4 different measures of precipitation for every location in the US for every season. Now, that's one spreadsheet. But if you'll notice here, I have 90 of these things, right? 90 CSV files in a folder representing precipitation from 1981 to 2010. So what I need to do is to start to combine these all. So let's jump back into ArcGIS Pro, and I'm going to walk through some steps. So I have a notebook here, and pretty much the first thing in all of my notebooks is to import the necessary Python libraries. So I'm going to be using Pandas, which is one of the most popular data science Python libraries, and I'm going to be using the ArcGIS API for Python. I'm also going to be using this library here called Globe, which allows me to work with file paths. So basically, all that I'm going to do to start off with is set the path to the folder that contains my 90 CSV files. I'll use this Globe function to basically say, okay, for each file in this file path that ends with a CSV, count how many of them there are. So we saw there's 90. And I could just display a few of them. So I see, the winter of 82, the winter of 83, the winter of 84, etc. What I then need to do is to combine all 90 CSV files into one table. So it's basically going to be every location with essentially 30 years times 4, 120 seasons, location number 2, 120 seasons of these 4 precipitation variables. So to do that, I'm going to use some Pandas functionality. So I'm basically saying, okay, for each CSV file in that folder, concatenate them together. And so what that then does is create for me a data frame that has about 57 million rows in it by 11 columns. Right? So I have all those coordinates, as you saw in the spreadsheet, and then each one of those 4 precipitation variables that we showed you. So it's basically taking all those CSVs and stacking them together. That's the starting point. And I can see here that there are 57 million records. Now, just for fun, what I could do is divide the total number of records in the table by the total number of locations. That gives me 120, and that means that I have 120 seasons of data, 30 years times 4 seasons. In all of my notebooks, one of my strategies is to check for null values. So I'm looking at that data frame, and I'm looking for each column. I'm looking if there are null values. I see here that a couple of my values have null values, but I'm okay with these. I know that basically any time where there was no rain, you can't calculate variability when there's nothing that happened. So I'm okay with this. There is no variability. Another strategy that I use in my notebooks is basically different cells to do experiments. So if I know that I'm going to be running calculations on 57 million records, I might have a couple of small tests where I say, okay, I'm going to just check for null values, or just run small bits of code on a smaller section of the data, so it doesn't take 5 minutes to run the cell. So I do have these sections in my notebooks often where I try some small experiments and then comment them out so I don't have to run that code. So let's continue on here. So I have my data frame, and what I need to do here is basically create a new column that just is the season. So you see here that I have the season year column. All the values in here say, winter of 81, winter of 82, spring of 83. What I need to do is basically create a new column that only pulls over the season. So I'm going to say, all right, create a new column. And I'm basically saying, create a new column where I take this input column season year and split it and only return the first basically the first set of characters. And so when I check the results, you see that I have a new column that's created, that's season. And if I look at that particular table, we'll see here that season year is what it originally was, and I've essentially stripped off only the season and dropped the year, right? And I need to do that because eventually I'm going to do some aggregation by season. So now what I need to do is get seasonal averages of these 4 different precipitation variables over 30 years. So I'm going to use a function called group by and basically say, okay, so for each location and for each season, take the average precipitation, the average number of precipitation days, the average Gini coefficient, and the average Lorenz coefficient. So I'm basically taking this big, long table and I'm shrinking it down by creating averages for each location and season. So what that then gives me, if I look at this table, I have, for this particular location, the average precipitation in the fall. For this location, the average precipitation in the spring. So basically 4 locations, 4 seasonal averages. Move on to the next location. 4 locations, 4 seasonal averages. So I've shrunk this table by averaging. And if I do a little bit of quick math, I'm basically dividing all the records by the total number of records in the new table, which we see here. And I'm getting 30, which means that, yes, I have 30 years of data, 4 seasons per year, and I could validate that there. So again, this is another strategy that I'll use. Just, okay, my output table has this many rows. Does it make sense, the number of rows that I've produced based on what I've input? So I constantly check my time along the way. Another thing that I have also gotten a lot of use out of is this magic command in a Jupyter notebook that it's % time. And this basically will calculate how long it takes to run each cell. So in this case, it only took 8.999 milliseconds, but in the case of one of my first cell runs, doing that big concatenation took 2 minutes and 23 seconds. So this is a good practice to get into to print out how long it takes your cells to run for the next time you run your notebook. All right, so a couple of more steps here. Eventually, what we need to do is to actually pivot our table. And so pivoting the table, we basically end up with an even smaller set of rows where we now have, for each location, we have the seasons as rows now. So really all that I'm doing is kind of taking a table and kind of manipulating it, shrinking it, averaging, spreading it out wide, and so on and so forth to prepare my data for the analysis. I've done a couple more steps here to clean up the table. I had to do one thing which I think was interesting at the end here, which was to basically take a column that has the coordinates combined in it, and I had to split those out such that I could take advantage of, something like just GIS, where I now have a column of X and Y coordinates. I then used the spatially enabled data frame to actually create a spatially enabled table, which gives me a shape column. So I actually have geometry, and then I could actually write that out as a feature class. So if I click over to my map, I turn this layer off, what that basically produced for me, if I zoom in, was a point data set on my map, where if I click on any one of these points, you'll see here that I have all 16 of those precipitation variables calculated. So in this particular location, the average over 30 years in the fall was 23 days of rain, right? And then vice versa. Now, a few more steps here. My end goal actually was to actually aggregate these smaller points to create a larger point data set. So I actually had another notebook to do this, where basically I had to go from a 4-kilometer grid to a 16-kilometer grid. This involved several different geoprocessing tools. When I have to string together multiple geoprocessing tools, I often use Model Builder. And so this idea of using Model Builder to then create custom tools is possible. So basically, when you build a model in Model Builder and you make it a parameter, you could actually expose those parameters as a regular geoprocessing tool. And anytime that you have a geoprocessing tool, you could click down in the bottom right corner to copy the Python command. And this goes for custom tools or non-custom tools. And then when you're in a notebook, you could simply paste, and now you have Python code that represents that particular geoprocessing tool. So it's, again, a nice way to kind of tie together Python with ArcGIS. So basically in this notebook, I used basic Python to import my custom tool. And then for each one of those variables, each one of those 16 precipitation variables, I basically just made a small loop where I say for each of the 16 variables in the list, run the aggregation tool. And what that ended up allowing me to have, again, is now instead of the 4x4 kilometer data set with the 16 variables, I now have a more coarse data set, again, with those same 16 variables. So it was like stringing together a few different tools and doing a little bit of automation with Model Builder to do this spatial aggregation. So in the last few steps here, I was able to run a few other different tools. In my case, given that I have 16 variables, I wanted to actually reduce the dimensionality of that data set. And so I chose to use an ArcPy tool called dimension reduction, which is principal components analysis. It allows you to reduce the number of columns, the dimensionality of a data set to a smaller numbers, the smaller number of variables that still maintain as much variation as possible. So I ran principal components. And the last thing that I want to highlight here is that within ArcGIS, we have different cluster analysis tools. However, I was interested in a tool that ArcGIS doesn't have. And so again, because you're in Python, because you're in a notebook, it's very easy to reach out to a open source or another library from the Python community for a particular type of technique or a particular algorithm that perhaps is not built into ArcGIS. So in this case, I'm reaching out to a library called scikit-learn, which is a very popular machine learning library for a particular clustering algorithm. And so in that case, I was able to create a data frame and then eventually to actually run the cluster analysis, agglomerative clustering, on my data set, choosing for 13 clusters. I could then write that data back out to my geodatabase, in this case here, as well as run a comparative clustering algorithm, which allowed me to then produce my final maps, which were, again, starting off with these kind of state boundary driven clustering regions. I have one cluster solution for precipitation regions based on open source Python and one based on a tool that's in ArcGIS. Both run via Python code. So I hope that this was, I know kind of a quick, but I hope that this was a good example of how you could bring together sort of the best of ArcGIS with the best of open source directly in your GIS, next to your maps, next to your data, and using these notebooks for analysis and data science. So with that, I will stop my section and we could move on to some different workflows with Manushi.
Okay, thank you, Nick. Yeah, so I will be delving into a different set of demos today. We'll be looking at administration and content management workflows for automation and scripting. So in the interest of this demo, I've already run most of these notebooks already, so we can focus on looking at the actual code and the scripts that built these workflows. So we'll start by looking at automating tools to manage ArcGIS Online organization. So as an ArcGIS Online organization administrator, this is something that you can very easily run and use to get a quick health check of your organization. So in order to do that, let's start by this first demo here for getting user history. So using the admin method, like or the admin submodule, you can very easily get the user history for your other usage history for your particular organization. So using admin.history with the start time and end time of choice. So here we are calculating a start time for the past, start time for now and the end time for the past 10 days. So for the past 10 days, we're basically getting a quick snapshot of what usage in my organization has looked like. So it looks like most of the people in my organization have either been updating their content items or just simply logging in. Some have been deleting content items and adding, and then it follows with the rest of the other functionality and capabilities within the organization. So using the admin history, we get a quick snapshot, visual snapshot using Matplotlib for how your members in your organization are using the different capabilities. Now you can also generate reports for the organization. So you can generate a number of different reports, such as content reports, credit reports, usage reports. We'll be taking a look at two of these reports. So in order to do that, you just run the report method of your user type and then or user object, and then specify the kind of report you want. In this case, we've specified content, and it goes ahead and creates this particular new item for us that has all the metrics for the content report. We've then gone ahead and accessed this in the form of a temporary CSV file. You can download this file onto your machine. You can also then use it for other analyses, other sorts of quick metrics and exploratory and descriptive statistics. So once we have this, we're reading it in the form of a pandas table. And we see we have a whole lot of statistics that the content reports give us. For each content item, you have the title, the item ID, you have the type, item type, as well as the date it was last modified, as well as when it was created. You also know who the owner is, and even important things such as the file storage size, as well as the number of comments it has, if it's a publicly shared item open for public comments and public engagement. And you also see tags and other important metrics. And then using that table, here what we're doing is we are sorting it based on file storage size to see which items consume the most amount of space in my organization. How does that really help? In case I'm feeling that I have a lot of data here, I feel there's a whole lot of bloat in terms of content in my organization, it helps you get a quick snapshot of which items are taking up the most amount of storage space. You can also generate credit reports. So the way we saw previously, using the report method of the user object, you can create a report. Here, we are specifying report type as credits. By specifying that and the start time and end time of choice, you can then generate credit reports for a specific duration. Here, we're generating weekly credit reports. Once we generate this report, we are getting the data in the form of the CSV file like we saw previously, and then a pandas data frame. However, we are now doing some simple manipulation to this data set. We are transforming it, and then once we've transposed this, we are then displaying it in a format that is helpful to us the most. In this case, the way we've transposed is it for each particular credit consuming service, we're getting a total of the number of credits that have been used there. So it turns out for notebooks, my organization is consuming the most number of credits, followed then by closest facility routes, like a routing tool, and then demographic maps and feature reports. How does this help us? Using this, you can actually get a sense of what the credit consumption of your organization is, and that in the future will help you with credit budgeting. So you know which services need to be allocated more credits versus which need to be allocated fewer credits. We can also use are various search methods within the Python API to monitor sites. So the search and advanced search methods are two very popular methods that allow administrators to quickly query your entire GIS organization, both for online and enterprise. We are seeing this with respect to ArcGIS Online, but you can also do it with respect to enterprise. And that way, once you search, you can then also specify certain search query parameters of choice. So here, the query parameters we've basically given are, we want to know we want to rather search for items that basically have been created within this timestamp of choice. So essentially, we're looking for items created in the past 7 days, as we see right here, and then those that are within my organization. So it doesn't fetch external items. And then once we sort these based on item type, we see that most number of items created have been of type administrative report, since we've just created a few right here, and then followed by feature services, story maps, file geodatabases. So this is also a very useful query to find out what are the most items or which item types are the most popularly created within your organization. So that also gives you a good idea for how content is created and consumed within your organization. You can also then validate metadata for these newly created items. So for the same timestamp, that is the past 7 days, we are now trying to find out which of these items have metadata fields populated. So with metadata fields, what we mean are descriptions, snippets, tags, thumbnail. Once you know like which of these items have metadata and which don't, it helps you then also understand which ones need to be populated, or rather which items need metadata populated well enough. And then you can also reach out to the owner of those specific items. Like we see right here, it tells you who has created a specific item which is not populated with metadata. To then, for a sense of awareness and accountability, it then helps you get a sense of whom to contact to have these items clean and end user ready for consumption. Adding metadata adds a level of trust, and knowing whom to contact to update these metadata fields is only going to help release good quality data. You can also do user searches. So using the same advanced search method, but on the user's or the user manager object, as opposed to the content manager object we saw right here for content search, you can then go ahead and also search for users in your organization, and you get a whole list of all the users that have logged in your organization. Using that same concept, you can then also proceed to see which users have not logged in the past 90 days. So writing a quick query of this nature, you can then find which users have not logged in, and fetching that list helps you also then get a sense of which users need to be contacted in order to, have them log back in and get back to their work, or probably even disable these users in extreme cases. Now we saw how administrators could probably manage their organization and online. Now for enterprise, let's see how an organization administrator can manage their enterprise organization through portal and server logs. So in this case, we're basically logging into our particular enterprise organization through this notebook, enterprise notebook. And I'm specifying my number of days. So for the past 30 days is when I'd like to fetch portal and server logs, and also all the metrics associated with it. So once here, I'm computing this time frame, and I'm fetching portal logs using the logs property of the admin submodule. So gis.admin.logs in this case is going to give me my portal logs. And then for the start time and end time of choice, I fetched the portal log results and plotted it in the form of a simple bar chart here that gives me a quick snapshot of the nature of these logs. So it turns out most of the messages or log messages in my portal have been of the nature warning, and only few have been severe in nature. So that also gives you a quick health check of your organization. You can then go ahead and also print these portal logs, or even extract them in a CSV, but you can print them in the form of a table to review the log message for each of them and the time stamp for when these messages were generated, and also the machine where it was generated. So that also helps you diagnose issues, if any, like especially in the case of a severe log. You can then go ahead and fetch server logs by using the servers property of admin and calling the list method of servers. This gives you a list of all your servers that have been federated. And at this point, you can choose which server you'd like to see the logs for. In this case, we're going to choose the server with index 5. So in this case, it's going to be the knowledge server. For the knowledge server, I've gone ahead and again, similar to portal log, specified the timestamp of choice. So the past 30 days, and I've fetched the log messages for it. And I've displayed it in the form of a pandas table. Now that I have this table right here, again, I can like explore the log message for each kind of failure that has been reported in the past 30 days. I can also see the timestamp and also the source for where this particular log message has been originating from. And this also can then be extracted in the form of a CSV table. You can also use the built-in reports for any particular server and then get deeper, more enhanced statistics and metrics for a particular server. So that can be done using the server.usage.list method, and this gives you the specific built-in reports for that server. In this case, we'll still be looking at the server for the knowledge server. And once you have that, you can then go ahead and use simple matplotlib methods to then plot this in the form of a particular bar chart as we see here. And for the past 1 week, as we see right here, we're getting the maximum response time. And this tells me what on what day the response time has been the highest in seconds and when it has been lowest, and based on also the time of the day. So as we see, probably in the second half of the day or the later half of the day, we're seeing higher response times as opposed to the earlier half of the day. So that also is a very key metric to keep in mind for future logging and monitoring tasks. Let's now shift gears and look at a few content management automation workflows. So this is a very key workflow, especially when we have multiple organizations we are managing or content spread across multiple organizations. Sometimes some things are probably on a staging site, staging org, and they need to be moved to production. So cloning a group and its associated content is, while a multi-step process, it can be really automated through this 5-step process as we see here. So we start by logging into the particular organization where the original group and its content sits that we'd like to clone. We then go ahead and specify the group ID for that particular group we'd like to clone. And we also log in to the target organization where we'd like to clone this group and its related content. So I've gone ahead, logged into my other organization on enterprise that I'd like to clone this content in. And I've specified the target folder name. So within a folder in my target enterprise organization, I'd then like to go ahead and clone all of this content. So from my source organization, I now fetch the source group based on the item ID I've provided right here. And then I fetch items for this group. Turns out it just has one feature layer called England temperatures for 2024. I then go ahead and use the groups.clone method of my second GIS. Second GIS being the target organization where I'd like to clone this group and content. And then I verify that this group has been cloned in the other organization. Once this group has been cloned, I now go ahead and clone within the second organization, the target organization, the items for within the group that I'd like to have cloned as well. Once I do that, I also specify the target folder name where I'd like to have this cloned, which we've specified right here. And then this just goes ahead and clones all of the content within the cloned group, and it'll print you a success method if it clones successfully. So as we see, this is a very quick and short workflow for many popular tasks or many tedious tasks to do tedious to do manually. And all you need to manually provide here is the group ID that you'd like to clone, a target folder name, which is basically optional, and you just need to log into your target GIS. Once these things are provided, the rest of the notebook can be automated as clockwork. Another content management concept I'd like to touch upon is for dependency graphs. So dependency graphs are graphs that you can create that help you see how content items within your organizations are linked or connected to each other. So sometimes, like a classic way to explain it really is that web maps have layers within them, so they are connected. And also sometimes there are apps that contain these web maps. So a story map could contain a web map, or a dashboard could contain a web map. So all of these linkages are maintained through dependency graphs. So what I'm now doing in this notebook is, instead of taking a particular web map or a particular story map or dashboard and then seeing all the linkages within it, I'm going ahead and creating dependency graphs for all the items within my organization. So what I'm doing right here is going back and using that search method that we saw previously in the administration notebook. And then I'm giving it a query where it searches for all the organizations that have been created by me, so that, I can at least look and get a sense of which items on my, or which items that I own are broken, or which ones need, further linkages maintained and enabled. So what I'm doing here is I'm fetching all the items that I own. And then turns out I have 591 items that I own within my organization. I've gone ahead and created a dependency graph for it using the create dependency graph method of apps.item graph, this submodule within the Python API. Once I create a dependency graph, I can then sort items by degree. So if I want to find items that are directly contained by a particular item, so like a web map contains a web layer, then contained by, so like a web layer is contained by an item, so like a reverse dependency, then node dot requires are going to give you deep dependencies. So if a story map or dashboard contains like a web layer, that's a deeper dependency, and a deep reverse dependency. So like a web map or a web layer, a feature layer is contained by a dashboard or a story map in a reverse capacity. So all these four levels of dependencies, or four levels of connectedness, are supported within the Python API. Once you choose the particular connection or the level of connectedness that you'd like to sort items by, you go ahead and then create it in the form of a pandas table. This pandas table, as we see right here, gives you for each item its title, its item ID, the item type, and the degree. So the number of other items it is connected to. So this level of connectedness tells you how important an item is and which ones then to enable or disable delete protection of to protect it from accidental deletion, or to probably reassign it to a more important owner, or what have you. And then this table for all the other items, the 519 items that we saw previously that I own, 591, sorry, we can go ahead and export in the form of a CSV. This concept can also then be expanded a little further to find which items are impacted by broken dependencies. So broken dependencies can be thought of as an item which is accidentally deleted, like we discussed previously, or items that are cloned from one organization to another, but have corrupted JSON structures in the process, or their data has been corrupted along the way. So whatever is broken can also be detected using the dependency graph concept. So we go here and using the same concept, we fetch all the items within the organization, create a dependency graph for it. Now that I have all of these, I'm going to go ahead and find broken dependencies. So in this case, we are using the required by method to find all the reverse deep dependencies. So which items contain this and which are impacted by this. And then we store this again in the form of a pandas table, as we see here. Similar concept as the previous one. And then you can also print out the final results for this. So my content has 244 broken items out of the 590, with a total of 1375 impacted dependencies. So the reverse dependencies also tell you how many items have been impacted, and then you can also get a count for it, count for it in the form of a table. So for each broken item ID, you can get the total count of how many dependencies are impacted by it, and then also which ones are they specifically. And once you have this list, it also tells you which items need to be gone and cleaned up, or which ones need to probably be updated or deleted or retired for permanent use. And this can also be exported in the form of a CSV to then inspect and diagnose other issues further. And on that note, let's go back to our slides. So we saw how administration and content management workflows can probably be automated and scripted. And I'd like to conclude with a few resources. There we go, finally. Yeah, I'd like to conclude with a few resources here. So these are a few great blogs that Nick has written regarding the demos he showed us for end-to-end spatial data science and analysis using ArcGIS notebooks. So I highly recommend reading these notebooks if you're interested in the demos he showed us previously. And yeah, it's, just a few documentation links to leave you with. So this is for ArcPy, and everything else is for the ArcGIS API for Python. So this is the official guide for the Python API for each of these subjects we saw, as well as a link for sample notebooks that give you end-to-end workflows, as well as the API reference. So the place where we have all of the methods, all of the modules and submodules documented with their syntax. And yeah, thank you for coming out today. And yeah, back to you, Amy.
Great. Thank you so much, Manushi. We're going to leave that resources slide up just in case so you can take note on that. I know there were a number of questions about where you can find some of the samples, the code, the scripts. You can find that information there. We're now going to address some of the questions that were submitted during today's presentation. As a reminder, you can still submit questions throughout this entire presentation within the Q&A tool at the bottom of your screen. One of our questions that we received today was, are there any plans to allow scheduling of ArcGIS Pro notebooks to run?
I could take that one, and I think short answer is it's been something that has been inquired about before, but we don't have any plans to do that right now. I mean, one of the most common patterns that we do see with customers is that they will author their notebook in ArcGIS Pro and then upload that IPYNB file to Online or Enterprise where you can schedule it. But we don't have any plans to do it in Pro at the moment.
Okay, great. Thank you so much. Which workflows do you use Python in ArcGIS for?
I could take a stab at that one too. So I think the possibilities are kind of endless. I think today what I showed in the beginning was several examples of using Python and ArcGIS for analysis for data science. There's 2,000 geoprocessing tools in ArcGIS Pro that you can have Python syntax for. So analysis, data science, and I think Manushi showed some really popular ways to do it to administer your organization and understand kind of things about your content and your users, as well as to manage content. So possibilities are endless.
Yeah, basically everything that's in ArcPy and the ArcGIS API for Python, all of that can be leveraged using notebooks.
Okay, great. Where you made mention of importing the necessary libraries, how can this work for an organization that has multiple agencies? For example, there's one central admin where users are managed. However, each agency has their own local server and portal as well. All agency does share the central server with organization login, and then alternatively, we have a portal login.
If the servers are federated on the on the host enterprise deployment, I think it's easy to fetch the list of all the servers as we saw, and then you can choose whichever server you'd like to get logs for. So the admin will have access to all the federated servers.
Okay. Great, thank you. In which ArcGIS application do you write and run Python code? Pro, Notebooks, or a different IDE of your choice?
You could do whatever you want. So Pro has a notebook environment. It also has a window, a Python window, which is kind of the original way that you could use Python. So you can use the Python window or a notebook in Pro. You could use the notebooks in Online or Enterprise, or you can use whatever IDE of your choice you want. So we have a lot of customers who prefer Visual Studio Code to write their Python code. So it's kind of up to you. Wherever you could write Python code, you could use these libraries.
Great. We had a question come in. Can you speak to the use of AI for creating Python code for use in GIS? This individual's had success using Model Builder to create basic code and then converting that to Python, then running it through ChatGPT iteratively to refine and enhance the code. What sort of, as a tag-along question, what sort of issues should they be on the lookout for?
You want to take this, Minushi, or?
Sure. Yeah, I was going to speak about the Notebooks Assistant, which is now available in beta in ArcGIS Online. So, of course, you can use that, and you can obviously leverage the assistant to write and even troubleshoot the code you've written. But at the same time, things to keep in mind are obviously it does not understand context. As no generative AI tool really can. So at the same point, you need to have the whole back and forth with it and work with it as opposed to just outsource your code writing to it.
Okay.
Just to add on to that, aside from AI, the Notebooks product itself has it ships with a maybe 30 Python code snippets.
Yep.
And it also has template notebooks available for it. So even though this is not on-demand AI generated Python code, we do have sort of pre-canned snippets that you can inject into your work. And then one other thing in ArcGIS Pro, there is a Pro assistant that also has a beta offering. Then there's an ArcPy assistant in that. And one other thing, comment about the chat GPT and coding and so on and so forth. One of the advantages of using the assistant that's built into the ArcGIS notebooks is that it's not just going to generic GPT for the code. While it is using an LLM service for that, we also use an approach that makes sure that it picks the most recent version of our documentation, right? So like every time there's a new release of the software or the new release of the Python API, for example, or ArcPy, there could be new functions, there could be new methods, there could be slight tweaks to parameters. So one of the things that is a disadvantage of using one of the open LLMs is that you could be generating code from a version 2 or 3 releases earlier, which means that things might not work. So that's something to be aware of as well. Because those LLMs are only as smart as early as recent as what they've been trained on.
Yeah, thanks for that, Nick. And also, at times, it tends to hallucinate based on what is not in the documentation, whereas the Notebook Assistant is trained to work with the most recent documentation. So, yeah, the odds of having as close to correct code as possible for these tools is likely with the Notebooks Assistant.
Okay. Thank you both. Are there any plans to enable webhooks to trigger running the hosted Jupyter notebook?
Also a good question. So as I mentioned, the notebooks that are in the hosted Jupyter notebooks, there is a version of those in ArcGIS Enterprise. You can use webhooks there, feature service webhooks and organization webhooks.
Organization.
In Online, they are not there yet. We've heard about this from many customers. It's an active R&D effort on the behalf of the team. It's just a matter of us kind of figuring out if our internal infrastructure could handle something like that, or how our internal infrastructure would handle all that event-driven automation. But certainly being looked at very closely right as we speak.
Okay, great. Does the create underscore knowledge underscore graph function demoed, does it require the license for ArcGIS Knowledge?
So I think I should create dependency graph. But create dependency graph, no, it does not require any licensing. So that works with all the items in your organization. We do have within the new release that literally went out this morning. So we have a new release of the Python API, but yeah, that allows you to convert the dependency graphs that we saw in those demos to knowledge graphs. That, yes, will require a knowledge graph license or the server setup. But yeah, the dependency graph, the two demos we saw do not require any licensing. And they do not even require admin access. You can run it for your own items.
Okay, thanks, Manishi. From this user, we're trying to combine the two separate reports for users and items, place the data in a dashboard, and have this automated. Can this be done with these libraries?
Do you mind repeating the question, please?
Sure. This user is trying to combine the two separate reports for users and items,
Okay.
place the data in a dashboard, and have this automated. Can this be done with these libraries?
Yes, you'll have to ensure that the new items that are created for these reports, the content reports and the user reports, it's just overwriting the same item. And that item ID can be set up as an input to these dashboards. So that as the item is updated with fresh data, the dashboard reflects the same updates to the same item.
Okay. How does ArcGIS handle real-time integration with enterprise SQL databases like SQL Server or PostgreSQL, especially for large-scale infrastructure data sets?
I am not aware.
I
Nick,
don't
do you
think
want
I
to
know
take
the
that?
answer to that question
Yeah.
either.
Okay, all right, we'll skip. Is there a good script or guidance on swapping layers within web maps and helping account for any issues like pop-ups and other web map configurations?
Yes. So if you go to this second link here for the guides, we actually have one under the dependency graph section that helps you with remapping data. So if any web map layer of yours you feel needs to be swapped with a brand new one, you can use the remap data method. We have a whole work like demo and workflow there for how to do that. You can swap it with replacement IDs.
Okay. Last question here. For what applications would I use ArcPy, and then when would I use API for Python?
Nick, do you want to take that? I can
Yeah,
go
sure,
otherwise.
sure.
Yeah.
So, I mean, there is some overlap between the two, but generally the ArcPy stuff is it's similar to what like if you worked in ArcGIS desktop, if you worked in Pro and you have geoprocessing tools and you have scripts that use geoprocessing tools, that's where I would mostly use ArcPy. If you are interested in, if you're thinking about things like online or enterprise and you're working with feature services and feature layers and creating reports for credits and looking at users and licenses, then I would use the Python API. If it's Pro related and geoprocessing, ArcPy. If it's about the WebGIS, Python API.
Okay, thank you. And just to add to that, they can work together. It's not an either or situation, but yes, it's desktop GIS versus WebGIS.
Okay, great. Well, thank you very much, Nick and Manushi, and thank you everyone for attending today's webinar, Strategies for Scripting and Automating Using Python. If you have any questions about this webinar, we encourage you to post them in the Esri Community user forums for developers that was posted in our chat, as there may be others who share the same question. And once you leave today's webinar, you will receive a follow-up email. We would appreciate it if you want to give any feedback. We're happy to receive that. And then on behalf of Esri and our presenters today, thank you for joining us today and have a great rest of your day. Thank you.